In this video we're going to take a look at a very useful function in the Django ORM, and that's the select for update function. And this function can be used with transactions in Django, and it works by returning a query set where the rows involved in that query set are locked until the end of the transaction. And that means we can safely update the data in those rows without having to worry about concurrent processes changing that data and leaving our database in an inconsistent state. So let's dive in now. We're going to look at the documentation here. We have the function select for update in the Django docs. And as it says here, it returns a query set that will lock rows until the end of the transaction. And it generates the select for update SQL statement on supported databases. Now this function is going to take advantage of locking mechanisms that are provided by the database under the hood, and we're using SQLite, which doesn't have these locking mechanisms, but this is supported on PostgreSQL, Oracle and MySQL. And in this video we're going to migrate our database from SQLite to PostgreSQL, and in order to do that we're going to use a Docker container and create the Postgres database in that container. Now the problem we're going to demonstrate here is as follows. If we go back to the code and we go to the models.py file, we have the order and the product models from the previous video. And when a user places an order, the number of items is specified for the given product, and when that order comes through, the number of items should update the number in stock for that product. So for example, if a user orders 2 books from the system, the product here is the book, and the number in stock should be decreased by 2 in that case. Now in the last video we talked about the problem where, for example, an order might be placed for those 2 books, but before the product number in stock can be updated, the system might crash, and therefore you have the order in the database but the number in stock has not been updated to reflect that order. We solved that problem in the last video using transactions. We have an atomic transaction here, and we are generating the order within that transaction, and then we are decrementing the product's number in stock. So the order is created and the number in stock is decremented as part of a transaction, which means if there's any problem in the middle of that transaction with any of those operations, then the whole thing is going to be rolled back and the order itself will not be created. We're going to show a different problem in this video, and it's related to transactions, but it is a slightly different problem. If we go back to this page, let's imagine that we wanted to order 2 books from the system, or rather 1 book from the system, and there are 2 books in the database in stock. So we have 2 books in stock. When we submit this order, we expect the number in stock to be decremented, so it's going to go here from 2 down to 1. But the problem is, imagine 2 people place this order at exactly the same time. The number of books in stock is 2, but 2 people are placing an order of a single book. That should reduce the number in stock to 0, but if they both read the value 2 at the same time, each of them are going to place that order, and that is potentially going to send the wrong value back to the database here when we decrement it by the number of items that have been ordered. And just to demonstrate why this is, we have 2 users placing an order, so there are 2 transactions against this database table. Those orders will be created, and within those transactions, each one of them is going to read the number in stock as 2, and it's going to decrement that by the number of items that have been ordered, which is 1. So the resulting value for both transactions is going to be 1. So even though 2 users are ordering a single book, the number in stock is not going to go down from 2 to 0. The final value is going to be 1, and that's because both users have read the value 2 here and decremented it by 1 at the same time. So it's a concurrency problem that can exist when you have multiple transactions that are updating a piece of data in your database tables. Now to prevent such occurrences, we can lock the product that's being extracted from the database using the select for update method. Now as I said earlier, in order to do this we are going to need to use Postgres, and that's because SQLite will automatically lock all rows when any transaction is in progress. This is a problem that can occur though in larger databases like Postgres when we have multiple transactions. Now in order to install Postgres, we're going to use Docker here. You can copy the Docker pull command to your clipboard and you can run that in the terminal in order to download Docker. So I'm going to bring up the terminal here, and what I'm going to do is run Docker pull command, and that's going to pull the Docker container from Docker Hub down to your computer. Now if you don't want to use Docker, we have also the ability to install Postgres on your operating system. So this is the page, which I'll link in the description of the video. You can click the download button and you have downloads for different operating systems, and then you can set up your local database, your Postgres database, on your local machine instead of using Docker. But if you are using Docker, you can download Docker Hub from this page here. I've got Windows at the moment, but there are downloads for all operating systems. Now I'm going to go back to the Docker Hub page for Postgres, and if we scroll down here, we have a sample command in order to start a Postgres instance. And what that's going to do when we run a command that's similar to this, it's going to start a container that is running PostgreSQL, the database server, and we can then connect to that database using Django. So what I'm going to do is use an altered version of this command. I'm going to go back to the terminal where we pulled that Postgres container, and I'm going to paste this command in here. It's the docker run command, and the name of the database that we're going to create here is ORMDB, and we're setting an environment variable for the Postgres password. I'm just going to set that to test for this video. And finally, we have a port mapping, and that's port 5432 in the container to port 5432 in the host. That's going to allow us to connect from our host, which is the local machine, into that container on the same port. And finally, the name of the actual image that we just pulled is the Postgres image. We're going to use that to actually build the container. Once we run that command, we're getting that the database system is ready to accept connections here. So what we're going to do is we're going to go to Django's settings.py file. So I'm going to open that up here, and if we scroll up here, we have a databases setting. And when you create a Django project, by default that is going to connect to a SQLite database. We're going to change this engine to PostgreSQL, and in order to do that, I'm going to go back to the Django documentation. There is a setting for databases here. I'll leave a link to this in the video. We're going to copy this setting here, and that's because that's connecting to Postgres, and we're going to fill out the details below that within that setting. So let's paste this into settings.py. Now the name of the database is going to be 𝗰𝗵𝗽𝗁, we'll call it that, and the user that's going to connect is just going to be the Postgres user, and the password is the one that we set as an environment variable on the docker run command, and that was just test. And of course, in a real database, you want to extract these into a configuration file that's not sent to GitHub. We don't want to just store the password as a raw string here. And our host is localhost, and the port is 5432. So let's save this file, and we're going to go to the terminal now. What we need to do in order to connect to Postgres from Django is install the Python Postgres driver here. So I'm going to use a pip install command, and the name of the package that we're going to use is this one here. So what I'm going to do is we're going to actually just copy this pip install command, go back to the terminal, and we can paste that in. That's going to install this package that's going to allow us to connect to PostgreSQL within this Django environment. So we have that installed. What we can now do is test the connection by running the server, and hopefully we're not going to get any errors, but in fact we do. And the error that we're getting at the bottom here is that the database ORM series that we're trying to connect to does not exist, and that's the name of the database here that we're trying to connect to. So we need to create that database on our Postgres container. Now how do we do that? What I can do is run the docker ps command, and that will give us all running containers. You can see the Postgres container is the only container that I have running, so we can connect to that container ID, and what we can do is run a command that's going to allow us to create a database in that container. And that command is the docker exec command, and to that command we can paste this ID in here. That's the Postgres container, and we can then place a command that we want to run, and the command is create db, and we're going to give it the name ORM series. Now when we execute that, we're getting an error that the role root does not exist. We can specify a user here to the create db command, and that's the Postgres user. That's going to allow us to then create that database in the container. So just to clarify, the container is this here. It is running a PostgreSQL server, and within that server we can of course create databases, and the one we've just created here is called ORM series. Hopefully now we can run the server and connect to this database that we have within the settings. So let's run the Django development server once again, and we now have the server running, and we have 23 unapplied migrations. So this is a new database. In order to generate the tables, we can run python manage.py migrate, and that runs through and creates all of those tables. And the final thing we need to do in order to set this up is go to our management folder, and within that we have a script called create data that we created earlier in this series. What we can do is run that script, python manage.py create data, and that's going to run through and create a bunch of objects in the database that we can now use and use it for testing in this application. Once the data is in the database, we're going to run the Django development server again, and we're going to go to the Django admin here. I've got a user called admin that I'm going to log in as, and we are going to go to the core application here, and these are the models that we've installed in the admin. The create data script should add data for restaurants, and you can see those here, as well as some dummy ratings as well. What we're going to do now is add some dummy products as we did in the last video, so I'll get back to this once I've added those. So I've now added some products. We have a camera, a video game and a book, and as I said earlier, there is a number in stock for each of these items. The book in this case has 3 in stock. Now what we're going to do now is go back to VS Code here, and we have this script here that we've been working with throughout the series. What we're going to do within this script is demonstrate what the select for update function does. So I'm going to copy the import of the transaction module from Django, and what we're going to do is basically define a dummy transaction that lasts a long time. So we're going to import the time module from Django, and let's set up a transaction here. So it's with transaction.atomic, and what we're going to do within this transaction is fetch a book from the database. Now that's the product model, so it's product.objects.get, and the name is going to be book. So I need to import the product model from the core.models file, so let's import that now. We're fetching the book from the database, and what we're going to do before we call .get is we're going to add a call to select for update. So we are calling product.objects.select for update and then the get function. And what this is going to do is it's going to get the book based on the parameters that we're sending to the get method, but it's going to lock that particular row, and it will return a single row because it's using the get method. That row is going to be locked, which means that other rows cannot change any data within that object, within that row, until the transaction is completed. So after we've fetched the book, let's call time.sleep here, and we're going to sleep for a minute, so 60 seconds. So this is the script that we're going to call. Let's bring a terminal over onto the page now, and what we're going to do is we're going to call that script with python manage.py. We're using the run script extension from Django extensions, and the name is ORM script. So we're going to run that, and it's going to fetch that book and sleep for 1 minute. And what we can do while that's sleeping is we're going to try and get this same book from the database in the Django shell. So let's open up shell plus here, and we're going to fetch that book with a similar query. It's going to be product.objects.get, and the name is book here, so we can fetch it no bother. We get that at the bottom, and we can access the fields such as the name on that book. But what we cannot do is update the book. So if we try and reset the name to something else, and we then call book.save, what we're going to see is that that row is locked. We cannot do that. You can see it's waiting at the moment, and that's because the row it's trying to update is currently locked in the database table. So you can see that's still locked, and if we bring this up here to the page, that is going to complete, and only when this completes will the book be updated. So that's the select for update method. What we're going to do is go back to VS Code, and we're going to go to views.py, and we're going to use it to solve the problem that we mentioned earlier, where potentially the number in stock will be accessed by 2 different concurrent queries, concurrent transactions, and those are both going to try and update this value, and that will result in the wrong final value being in the database. Now we're going to change the structure of the query a little bit. Before we call form.save, what we're going to do is we're going to extract the product, the book, from the database. Well, it could be the book, but it's basically going to be whatever the user selects on the front end. So it's going to be product.objects.select for update, and again the product model will need to be imported at the top here from the models.py file. So once we have that imported, what we're going to do is we're going to call select for update, and the question is, what product are we actually going to get from the database based on the order that's been submitted from the front end. We have this product order form here, and that was defined in the last video. It's in the forms.py file, and it has this field called product, which is the foreign key to the product model. And that's what you see on the front end here. We have this select box, and each of these represents a foreign key to the product table. So on the back end, we can access the product from whatever's in this field here, because that is going to be converted to a product model by the Django form. So let's go back to views.py, and we're going to call the .get database method here, and we're going to get the product by its ID, and the ID is going to come from form.cleanedData. I'm going to move this to a new line so we can see this. It's going to be form.cleanedData. And the key that we're looking at is called product. That will give us back the product model that was selected on the front end. And then we can get the primary key from that model. And we're going to pass that in as the ID lookup to the product's get method. So what's going to happen here is that we're going to find this product by its ID from the database. And the ID comes from the user selection on the front end. And then when we get back that single product, we're going to lock it. We're going to prevent other transactions from updating that data by calling the select for update method. So the product here is going to be locked, and that means that when we update the number in stock below here, that's going to prevent other transactions from updating that at the same time, and that will help to keep our database consistent for this particular field. And note that we can update the product's number in stock within this transaction even though the product is locked, and that's because this lock will be given to the transaction that is currently executing. This transaction here has acquired a lock for that row by calling select for update when it fetches that data, so that can update this, but nothing else. No other transactions will be able to do so. So with that code, we're now going to start Django's server, and we're going to go back to the front end and look at the form that we have on the page here. So we have this form that allows us to submit an order for a particular product. So let's submit an order for a book, and we're going to select 1 for the quantity of items. We submit that order and we get that processed on the back end. Now notice at the right hand side we have Django debug toolbar here. What I'm going to do is go to the history of the requests that have been sent to the server, and we're going to look at the post request that was used to create that product, or rather create that order in the database. So let's switch to that, and we're going to look at the SQL tab now, and we're going to see some of the SQL that's being executed. And one of these queries, it's this one here, contains the select for update expression in SQL. And this is the expression that gets the product with the ID that was selected from the front end. In this case, it's the product ID of 1. And it gets the data for that product, and the for update statement comes at the end. And that means that whatever rows are returned by that query are going to be locked. And that is what's preventing other transactions from modifying the data in that row when we are using this statement. And that's the crux of the select for update expression. In order to test this on the page, again, I'm going to go back to VS Code, and we're going to import the time module, and we're going to call time.sleep for 25 seconds here. And by doing this, I'm going to demonstrate a couple of arguments that you can pass to select for update. So when we submit the form, it's going to sleep for 25 seconds in the middle of this transaction that is locking the product that has been submitted. So let's go back to the front end here, and again we're going to select an order for the book. So let's submit that, and I'm going to bring up a terminal at the bottom here that has Django's shell opened. And while that request is in flight from our page, what I'm going to do is fetch the same product from the database, and we're going to try and update the number in stock to 10. So if we call product.save here, you can see that it's not saving immediately, and that's because this particular product is being used on the page. We've sent a request, and that product is therefore locked in the database until the request on the left hand side on the normal page is completed, and that is only completed after, I think it's 25 seconds I've put in here. After 25 seconds, the rest of the transaction will be completed, and then the lock will be released on this row that represents the product. And only then, once the lock is released, will the code in this particular function, or this terminal, be executed. Now this is important, of course, for any fields that need to be consistent when you have multiple concurrent requests that are updating values. But the drawback is that when you're locking rows in the database, any other requests that need to change those rows are going to have to wait until the transaction is finished before they can modify that data. So you need to wait on the lock being released from those rows before those rows can be modified by other transactions. And that can be a bottleneck in your applications if you have a lot of writes going on to different rows. So the select for update function is a tool that should only be used when it's required. Only when you need to lock certain rows when performing operations so that other transactions cannot modify that data at the same time should you consider this function. Now let's finish this video by going back to Django's documentation for select for update. You can see there are some keyword arguments that can be passed to the function. For example, there's a keyword argument 𝑛o_weight, which is by default set to false. And the 𝑛o_weight keyword argument is described in this documentation. And it's this behavior here. Usually if another transaction has already acquired a lock on one of the selected rows, the query will block until the lock is released. If that's not the behavior you want, you can pass 𝑛o_weight equals true, and that will make the call non-blocking. So let's demonstrate this again by submitting the form. I'm going to increase the call to time.sleep to, let's say, 80 seconds to give us a bit more time to do this. And what we're going to do is we're going to go back to the form and we're going to submit an order here for one book. And then we're going to go back to the terminal. And what I'm going to do is create a transaction here using the transaction.atomic function. So with transaction.atomic, what we're going to do is get the product from the database using product.objects.selectForUpdate. And this time we're going to pass 𝑛o_weight equals true to that. And we're going to try and get the product that the user has submitted, and that's the one with ID of 1. And then if we try and update the number in stock here, and let's say update that to 4, when we call product.save in this case, what we're going to get back is an error, and that error, as you can see here, says that we could not obtain a lock on the row in relation core product. And the reason now is that this is still submitting the form to the server. So what happens here is that we're sleeping within the transaction and we have a lock in that transaction for this product with ID of 1. So in the terminal, when we try and actually change that product within another transaction, when we call select for update in that transaction, this time we're passing 𝑛o_weight equals true here, which means that this call is not going to wait for the existing lock to be released. It's simply going to return an exception. So that's the 𝑛o_weight argument that you can use to prevent blocking calls to database resources that are locked. What we also have in the documentation is another keyword argument. This is the skip locked keyword argument. So what we can do, if we scroll down, we can see the behavior of that. And it's basically this line in the documentation. You can ignore locked rows by using this skip locked keyword argument. So let's very quickly see a demonstration of this now. I'm going to go back to the form, and again, I'm going to submit that book. And let's submit a single item to the database and go back to the terminal here. I'm going to scroll down to the bottom, and I'm just going to paste this code in here to be quick about this. We are again opening a transaction, and this time when we call select for update on the product that we're getting back here from the .get method, we're passing the skip locked equals true keyword argument. So let's now see what happens if we try and execute this. We don't get back the same lock exception this time. Instead, we're getting back a product does not exist exception. And that's that the product matching the query that we've provided does not exist. Now we know for a fact that we do have a product with ID of 1, but it's being skipped in this call, in this query here, because we have set the skip locked keyword argument to true within the select for update expression. So these two keyword arguments can customize the behavior when you call the select for update function to try and acquire a lock on a row or on a number of rows in a particular table. And that's all for this video. If you've enjoyed the video, please like and subscribe to the channel. And if you're enjoying this content, please consider buying a coffee to support the channel as well. And we'll see you in the next video.